All right, so we are going to call this topic 12.3. And I do a lot of different things, so let's just call it angles in standard form. Now, I feel like what you guys learned yesterday was stuff just kind of like a review from geometry and maybe a few extra new things. But this, I don't think you've done before, so this is going to be pretty new. And so we're going to think about an angle differently than you ever have before. So in the lesson from yesterday and the day before, we thought about angles like inside of a triangle. These, we're going to think about angles like a rotating ray. All right, so it's like we would take this ray and we would, hold on. And we're going to rotate it around to form an angle. All right, so I know that's different than what you're kind of used to with angles. So an angle in the coordinate plane is in standard position when the vertex is at the origin and one ray lies on the positive x-axis. So the ray on the x-axis is called the initial side. And the other ray is called the terminal side. So this one would be the initial. And then this one would be the terminal side. And that example that's drawn there, that is a counterclockwise rotation. And so the one I was showing you is a counterclockwise rotation. And that always results in positive angle measures. But there are also negative angles. So if we took that ray from the beginning, from the initial side, and we rotated it around in the clockwise direction, like that, that is going to be a negative angle measure. Right, and then you can see some, let me erase some of these things. All right, you can see some common angle measurements that you probably remember from geometry, but one new one probably is if we have the positive x-axis, that angle is 0 degrees. This one right here is 90 degrees. A straight angle is 180 degrees. And then if we went all the way around this way, that's going to be 270. What about all the way around, a full revolution? How many degrees is that? 360 degrees. Good. All right. So on this first example, we're just going to draw some angles. All right. So remember what the 0, 90, 180, 270 look like. We want to graph 75 degrees. All right. So I'm going to start at the positive x-axis. I'm going to rotate around. Since it's a positive 75, I'm going in the counterclockwise direction. You guys tell me when to stop when you think it's 75 degrees. Yeah, that's good. That's good. That's 75 degrees.
So it is.
Well, that's all that is. We're doing a lot more than that today. All right, so we'll do the same thing for negative 160 degrees. So I'm going to start at the positive x-axis, and this time it's a negative angle. So I'm going to rotate in the negative direction. So I know from here to here is negative 90 degrees. And I want to stop I want to stop when I get to negative 160 degrees. Right, we definitely needed to stop before we got to negative 180 because that's going to be a smaller angle. Okay, now 430 is kind of a weird angle because it's more than 360 degrees. So what's going to happen with 430 degrees is we're going to start here and we're going to rotate all the way around. And that's going to be 360 degrees. And then how many more degrees do I need to go to get to 430? So all the way around, that's 360. And then how many more degrees? 70 more degrees, which would be about right there. And then to label it, you have to show that like the full rotation. So you do like a swirl, and then that's going to be 430 degrees. So that's kind of different way to think about angles. Now, one of the main parts of your assignment today is changing the measure of the angle. So before today, probably, most of the angles you've thought about have been in degrees. But there's another type of measurement that's called radians. And in geometry, I don't know for sure, but I think they talk about radians just to make sure your calculator is in the right measure. I don't think you do much with radians. So let me tell you what a radian is. So a radian will take the radius of a circle. So this is the length of the radius of a circle. And what they'll do, or what you do, is you put that length along the edge of the circle. And what it makes, that angle it forms, is 1 radian. All right, so that angle right here, this angle, it's not writing, sorry. That angle is the measure of 1 radian. So it's way bigger than a degree. But that's what 1 radian looks like. So what I can do is I can take that same distance of the radius, and I'm going to put it along the edge of the circle again. Now I'm just estimating. Obviously I can't do this perfectly, but we'll just try to estimate. That looks about right. All right, and then that's going to form 2 radians. I'm going to do rad for radians. So what that means is this angle here is 2 radians. All right, I'll keep going around the circle with a radius along the edge. All right, so I'm going to keep going about right there. That's going to be 3 radians. I'm just going to put 3. It's fine. Now, I know for a fact that if this was a diameter, like it was a straight angle, there's a delay. It's taking me a second for this to work. That right there is 3.14. If it was a diameter. Is that a familiar number to you? Pi, yes. So half of a rotation, that's going to be pi radians. Okay, let's keep going around. All right, we're going to say that's 4 radians. 5. 6. And then a full rotation is going to be 6.28. What do you guys think that is? 6.28. That's 2 pi. All right. So one thing we're going to do a lot of today is convert degrees to radians and radians to degrees. So I know from looking at these radii around the circle that 360 degrees, a full revolution, is 2 pi radians. And I also know that half of a revolution, 180 degrees, is pi radians. So, because 180 degrees is equal to pi radians, we're going to use that fact to use that to convert from degrees to radians and radians to degrees. All right, so if I have degrees and I want to change to radians, what you do is you multiply by pi radians over 180 degrees. So let's do that for 30 degrees. Okay, so pi is going to go in the numerator. 180 degrees is going to go in the denominator. And when I multiply that, the degrees cancels out. All right. Now, we are not going to type pi in the calculator, so I'm going to write that over here. Don't type pi in the calculator. So when you want to go from degrees to radians, what you basically do is divide by 180. Or you can do like the little fraction thing and do division that way. And then after you get your answer, you're going to write pi on the top. All right, so we're going to write down the steps and then we're going to do them. It sounds more difficult than it is. Okay, so I'm going to go ahead for this little fraction guy and just do the alpha y equals. I think that's the easiest way to do it. Okay, so when I do alpha y equals, I'm going to choose number 1, and I'll get my little fraction. Right, so whatever the degree is, the 30 degrees, we're going to put that on the top of the fraction, and we're going to put 180 on the bottom. All right, and then we get that fraction, 1/6. All right, and then we're down to this purple step where we're going to write pi on the top. Sorry, there's a delay. So 1/6 is going to translate to pi over 6. Okay, now that feels kind of weird. It's okay, we're going to do it again. So we have 150 degrees. Technically what we're doing is we're multiplying by pi over 180, which cancels out degrees. In the calculator, we're going to do alpha y equals 1. We're going to put 150 on the top, and we're going to put 180 on the bottom. And I get that. And then we're ready to put pi on the top. So it's going to be 5 pi over 6.
Where'd you do it? So it's just like only if it's 1?
Yes. So on number 4, it was 1/6, so it's like 1 pi over 6. You don't have to write the 1 though. So on the second one, yeah, it's just pi. Yep. All right, you guys try 6 on your own, please. right, so you should get negative 11 pi over 9. Sound good? Okay. So when you're going from degrees to radians, you basically divide by 180. All right. So then whenever we are going to convert from radians to degrees, you multiply by what's the reciprocal of that. So you multiply by 180 degrees over pi. So that's what I'll do on these. So number 7, we're going to multiply that by 180 degrees over pi. What happens to the pi's? They cancel out. All right. And then again, it's just a calculator problem. So you can do that alpha y equals again to get the fraction for 4/3. And then we're just going to multiply by 180. And that's it, 240 degrees. Now on these, if you don't like doing that alpha y equals for the fraction, you can also just do 4 divided by 3 times 180. And it works the same way. So whichever you prefer to type it, it's up to you. Okay. So on number 8, same thing. We're going to multiply that by 180 degrees over pi. Cancel the pi. And then it's negative 5/36 times 180. And it should be negative 25 degrees. All right. So you guys try 9 on your own, please. All right, so 7/4 times 180 should be 315 degrees. All right, any questions? It's not terrible. Okay, now we are going to talk about one more thing today, and it is the coterminal angles, which is the first thing on the back. So let me explain to you what a coterminal angle is. I'm going to try and draw, I'll zoom in and draw it up here. All right, so let's say you have this angle that's right here, and this angle is 300 degrees. All right. A coterminal angle is going to have the same initial side and terminal side, but it's not going to be this rotation. So a coterminal angle could be this angle that I'll draw in a second. There's a delay. There we go. Maybe. Okay. Could be this angle. What do you guys think that angle would be? Negative 60 degrees. All right. So to get that coterminal angle, what Nolan did was take the 300 degrees and he subtracted 360 degrees from it and got the negative 60 degrees. Right? There are more coterminal angles. We could have an angle that also went all the way around, and then back to that point right there. So to get that one, you would take the 300 and you would add 360 degrees. So 660. So those are coterminal. They're not the same angle, but they have the same initial and terminal side. All right, so what we're going to do on these examples is give 2 coterminal angles, one positive and one negative. And to do that, we're just going to add 360 degrees and subtract 360 degrees to get our 2 angles. Now, it's possible you would have to subtract more than once or add more than once. I think we're going to do one of those. I'll show you what I'm talking about. But for 65 degrees, we'll just take 65 degrees and add 360. And that's going to be 420 degrees. All right, that's one of the coterminal angles. That's the positive one. And then to get the negative one, we'll take that 65 degrees and we'll subtract 360. And that's going to give us negative 295 degrees. And that's it. Yes, sir. Yes, thank you. Okay, so that's pretty much it. Once I get 540, we'll take 540 and we'll add 360 to it. And that's going to give us 900 degrees. So that's the positive coterminal. That is a positive coterminal angle. There's an infinite number of coterminal angles for each angle. But the thing about this one is when I take 540 and I subtract 360 from it, I get 180. Is that negative? No. So this is not going to be our negative answer. What do you think we need to do? Just subtract again. And I get negative 180. That's going to be my negative coterminal angle. All right. Now, we can find coterminal angles in radians, but I'm just going to stick with degrees here. Just knowing what you guys need to be able to do with this, I think that we'll just do degrees. And so number 12 and 13 are in radians, but we know how to change those to degrees. We'll just take those and multiply by 180 over pi to cancel the pi's. And then it's 13/18 times 180 is going to be 130 degrees. That is not a coterminal angle. That is the same angle, just in a different measure. So now what we'll do is take that 130 and we'll add 360 and subtract 360. All right, there's my positive and negative coterminal. All right, we'll do it one more time. So we'll change this one to degrees. All right, so you guys take 280 degrees for me, please, and find a positive and negative coterminal angle. All right, so we're gonna not do all of the worksheet today, but we will finish it tomorrow, most of it. But I want to tell you all something about it. So we're not gonna do reference angles. So if you look at your assignment on number 13 through 16, just mark out reference. Just for what we're doing this year, I don't think they're important, so I want to focus on what's important. So mark out reference on 13 through 16. And then also on the back, we're not doing them on 17 or 18. And if it was me and I was doing 17 and 18, I would change 2 degrees before I tried to graph it. Graphing in radians is pretty tough. Right. So today is just 1 through 18. We'll save 19 through 21 for tomorrow. So when you get done, just hold on to it for tomorrow.